Okay, so good morning, everyone. Good afternoon, depending on where in the world you're joining us in from today. We're really excited to do this launch webinar for you today. We're here to launch the TX01 electric air compressor, our next generation of the TX series of compressor packages, alongside the TX02 that launched a couple of years ago. So we've got some good information to share with you today. We hope you're going to find it pretty interesting and that you're excited as us here at Gardner Denver Transport Solutions with the launch of this new product. So a quick introduction then. So I'm Callum Dougal. I'm the lead systems engineer for the e-mobility sector of Gardner Denver Transport Solutions. So Gardner Denver Transport Solutions includes our transport products in Bradford and GHH Rand for dry bulk and liquid bulk handling, highways and utilities and truck hydraulics and things. And then our e-mobility compressor packages are based here in Redditch, and we are used for supplying the vehicle compressed air systems. So functions like the braking systems, the vehicle suspension systems, and the pneumatic door systems. On the call with me today, I have my colleagues Shashank Gupta Rakesh, Andy Webb and Justin Wilkes. So Shashank's my our project manager, and Andy and Justin are from our product management team. So they'll be in the background to help with the Q&A session throughout the presentation. So if you get the Q&A box up as the session's happening, please feel free to ask questions as we go along. They'll be happy to help you on those. And then we will be doing a separate Q&A session towards the end of the presentation, so I can answer questions sort of live then as well, and we can go back over any questions that that have been asked that we think are probably appropriate for the whole group. So yeah, make sure your questions come in. Those guys will help you, and then we'll do some at the end as well. So let's begin the webinar. So as I said, this is the launch of the TX01 electric air compressor package, our next generation and the latest evolution in the TX series, joining the TX02 product. This product has been specifically designed for the commercial vehicle market, targeting hybrid, fully electric and fuel cell vehicles. And this smaller size from the TX02 is probably looking more at the truck market than the bus market now, but we're taking the decade of dedicated knowledge that we have in that industry with new vehicle technologies, and we think that we've delivered an outstanding product that's probably best in class in the market, especially in terms of compact size and weight. So if we move on then to sort of an introductory slide for the TX01, and then we'll pick up some of the sort of critical vehicle improvements to the package we've made. So we've really targeted the lower flow rates and duty cycle capabilities with this package, and the new combined inverter and motor drive technology pairs well with our proven rotary vane technology, meaning that we give you the full package for your vehicle needs. So if we go down through the bullet points, one of the first things we've done is increase the speed range of this product. So we've got now a 20% larger flow range, which means we can hit the high flows that we need, as well as getting down to the low flows, which then pairs us with the lower duty cycle capabilities, which has been one of the things we've really targeted with this new TX01 product. So as standard, we can go as low as 10% duty cycles now to align with the air demands on the system. And we have strategies to help you get to that low target with the environmental conditions that we know are a challenge within the vehicle industry. Some of the vehicle critical requirements we know are sort of low emissions and weight and space. So we've done some further reduction in the noise emissions when we're looking back on the TX02 product itself, and the airborne noise and improvements to the structure-borne NVH is something we've targeted on this product. We'll talk a little bit more about that in some of the later slides. And then we've got up to a 32% weight reduction and 36% reduction in the footprint size when compared to those larger TX02 packages for the predominantly bus market. So there's some really exciting milestones we've hit there in terms of getting that weight and size down, because we know these are really vehicle critical requirements. The last two then on the list are more to do with sort of software and the new motor and inverter drive. So we've got some improved control strategies we'll talk about later on. Full CAN control compliant with the standard J1939, and with full UDS and DM1 diagnostics now as standard. And then also the high voltage interlock loop comes now as standard as part of the electronic controls and the safety strategy we have too. So if you move to the next slide then, if we talk a little bit more about these new features, so the low duty cycle capabilities, as we've said, the TX01 has specifically been designed for duty cycles to get as low as 10% running. So that's 10% of a 10-minute cycle. The larger speed range that we talked about allows us to still hit those high flow pump up requirement times for things like the Reg 13 legal time limits, but it also allows us to get those low flows so we can achieve the on-road tank fill requirements that we see in the real world when you're using only when you need to fill those tank times. To ensure that we can do those duty cycles across the larger environmental envelope that we know is critical for the commercial vehicle market now, sort of the -40-degree area right up into the high 60s. We've made some improvements, the minimum pressure valve, the MPV, which we'll talk about in some further slides. And we've introduced two new features to the strategy for low temperature running. So we've got a recirculation valve on the product now as a mechanical feature that helps us with the low temperature running. And we've also introduced a software feature, the minimum runtime feature as well, for some safety critical low temperature running zones. For the lower noise emissions, so we've optimized through design the internal geometry of our rotary vane compressor, the RSU geometry. And through testing, we have ensured that the free field airborne noise emissions are below 69 dBA at 1 meter across the full operating range. So that's at the highest speeds. In the recirculation mode, we're below the 69. And I believe if we go all the way down to the low speed end, we're under 59 dBA at that 1 meter distance. And with that internal geometry optimization, we've done some further balancing and reduction of the eccentric loads within the compressor. And this has allowed us to reduce even further our structure-borne NVH, which we have full testing and data for as well now, so that we are truly vibration-free as much as we are already on the TX02. We now have that in data form so that we can integrate with you. We can give you information for your vehicle dynamics and vehicle calculations as needed. The weight and space envelope reduction, 32% reduction in weight, 36% reduction in footprint. That's including the air intake filtration unit, the framework and everything. So we've done an improved cooler module. This is a water-cooled machine. We've done an improved cooler module to help us with that space and weight reduction. And then with the integration of our new motor and inverter combined unit and improvements to the frame design, combined with what we've done with the structure-borne NVH testing, we now also see no need for anti-vibration mounts. These are all things that we've done as part of the design and validated through testing to reduce that weight and space envelope, which is critical for the vehicles. That allows you to take more load on board and allows you to package us in a smaller part of the under chassis body. And then lastly on this slide, we've got the high voltage interlock loop. So I'm sure a lot of you are aware of the H-fill systems. Its function is obviously to ensure that the system shuts down if there's any interruption to the high voltage circuitry. This is a fundamental safety concern on the vehicles. The passive hardware for this is already included in every package we sell. So the wiring within the connectors, the high voltage and low voltage connectors is there. And then an active function can be enabled through the software if indeed you do want something to react to an H-fill incident. And that's something that we can, through partnership with you, build into your operation strategy and our control logic of the compressor. So moving on a bit more onto the actual mechanical functionality of the improvements we've been talking about there. So we talked about the minimum pressure valve. So if we talk about the basic functions of the compressor, you've got an intake valve that opens to draw air into the compressor. The compressor obviously compresses. And then we have what we term the minimum pressure valve on the discharge, which is our controlling valve on the discharge line of the compressor. So our minimum pressure valve now starts to open at a higher pressure, which ensures we're optimizing our oil management for the system. And the non-return function of that is now improved with a pressure feed to also isolate that for a stop compressor. So that will allow us to react a lot quicker to things like dryer purges and other downstream equipment to ensure that we have that optimized oil management. The two new functions we talked about, the recirculation valve, this has been introduced to, as we said, combat potential condensation issues at low temperatures and low duty cycle operations. So this allows us to recirculate a portion of the warm air to keep that inside the compressor so that we can remain hot in those offload conditions from the vehicle air system. This allows us to combat those potential condensation issues that we know compressors can fall susceptible to in those low temperature, low duty cycle operations. And in combination with this recirculation valve, as I said, we have the minimum runtime feature, which is built into the software. So at specific low temperature conditions, the unit then maintains a low speed run on, and this ensures that the internal temperatures do not fall below those critical limits. So we pair the minimum runtime feature with the recirculation valve, and that allows us to handle those larger environmental envelope conditions that we're seeing as part of the vehicle requirements now. So the diagrams on the right sort of show this a little bit. So at the top on figure 1, when there's the low system pressure on the vehicle, the MPV is fully open, we have normal flow, we're drawing in air and discharging it hotter than it is. And then at the bottom, when that system pressure reaches full, if we've not achieved an internal temperature that we deem is above the correct limits, we will then get that recirculation valve open and continue flowing within the compressor itself to ensure that we can maintain the temperature limits. If we move on to the next slide then, we'll talk a little bit about the software functionality. So we've improved the control strategies on the TX01 product. As I said, we're fully compliant to J1939 for the CAN protocol, and it now comes with the full UDS and DM1 diagnostics. Our 2 primary control modes we have as standard, as you'd be familiar with on the TX02 units, a speed control, which is a speed signal is sent via CAN to request the compressor to run. This is within the speed range limits that we'll be familiar with on the DBC files. And then the compressor will operate at the set speed given by that CAN signal. Then a signal of 0 will be sent to then stop the compressor, and that's some very simple speed control settings there, although obviously we can talk more about operation strategies with you as we partner with you to determine exactly what's appropriate for your vehicle systems. But the system can now also be configured to react to pressure readings over the CAN network as well. So if we define cut-in and cut-out pressures, which are fully user-definable within the software, we can work with a pressure signal readout on the CAN system to cut in and cut out the compressor purely based on the pressure of this vehicle system itself. So that allows for a slightly more autonomous control, and it will react directly to your vehicle tank systems. Fallback modes that we've put in place. So in the event of a CAN loss event, the unit will enter a safe mode. This can be defined to accommodate any customer safety strategy that we want. So that can be either the compressor stops completely, or we can have some sort of limp home mode or minimum run speed that will allow continuous supply of air if that is deemed the appropriate situation for your application. This, as I said, this can accommodate any customer safety strategy that you require. As usual, you'd expect thermal protection. So the compressor, motor, and inverter all have their own temperature readings, and each of those have their own cutback limits, and they derate the speed of the product as necessary to ensure that the product's kept at a safe condition. And then lastly, talking a little bit about the extended diagnostics, we have got the full UDS, Unified Diagnostic Services, built in now. So we can partner with you to ensure that you have exactly the diagnostic capabilities you want as part of the vehicle architecture. We have a range of data identifiers, DIDs, which can read system parameters, and a list of diagnostic trouble code signals, DTC signals, that are available as standard, and these can be linked to amber and red warning lamps as appropriate. And lastly, on there, we have the security access we can have now based on a seed and key mechanism. So this allows us that extra level of protection to ensure that nothing can happen to that software when it's installed on the vehicle. If we move now slightly more onto the technical data, so we've got a graph here, and this is showing where the TX01 sits in terms of the TX series. So if we see the dotted lines on here, we have where the TX02 flow currently sits. So we're going across up to sort of around a 3,000, 3,100 RPM speed. We get up to around 450 litres on the TX02 unit. We're bringing the TX01 underneath that now so that we're dropping down, and at the bottom end, you can see we get really beneath that 150 litre a minute limit, which allows us, as we said, along with the duty cycle capabilities, to really target the flow you need on the road as you need it. You can see there that we have extended the range, so up to the 3,500 to get the top end on the TX01 flow. So again, that allows us to hit those legal pump uptime requirements as well, so that we can cover the full range with the one product. And as you'd expect, you can see the drop in the actual power take from the new TX01 units when compared to the TX02, purely based on the fact that we're taking, we're delivering less flow, and that, as you can see, matches entirely and tracks with the TX02 units. The next slide then is a little bit of a breakdown of some of those key mechanical, environmental, and electrical data points. I will point out at this point that the data sheet and the launch flyer that will be sent out to you as part of the launch pack will include all of these details. And in fact, this presentation will be included in that launch pack as well. So if we look at some of the key mechanical data points for the new TX01 product, we've said duty cycles from as low as 10%, but we can still hit that 100% requirement. So we can do continuous run if necessary on the vehicles. The operating pressure range is anywhere from 7 bar up to 12.5 bar as standard. That's to do with the sizing of our recirculation valve. We can go to pressures up to about 13.5 bar if necessary. We just need to discuss the recirculation valve at that point, and it might have to come down to some sort of customer bespoke unit at that point, but that is something that we can accommodate. The operating free air delivery, matching with the operating speed range, so from 1400 RPM to 3500 RPM gives us the 160 to 380 litres that we'd see at a 10 bar discharge. That will slightly lower and raise depending on the discharge pressure, but all of that information will be available to you. The weight, as we said, including all the framework, all of the intake filtration, the upstream equipment that is necessary for the compressor, is around 41 kilos. That's including the wet weight. So we're talking the onboard coolant that's going through the system as well, and the oil in the system. And the package dimensions there, again, 540 by 400 by 290. Is again including that intake filter that we can see on the images on the right there. So we've got some nice side and top and bottom views. A little bit about the mounting strategy on that framework. We have 4 M12 bolt holes that come up from the underside of the frame, and the unit's been designed to be mounted across 2 chassis rails. So it would just require 4 bolt holes. The general assembly drawings that are part of the launch pack will show you what the patterns are for those holes. On the environmental data then, so the intake temperature range is from -40 to +65. That's been validated through our testing. If the intake position of that filter is moved to a remote location, then the actual compressor itself can be located in a warmer environment to be agreed. But if you are having the standard package with the intake filtration mounted in the same area as the compressor itself, then the temperature ranges from -40 to +65. As we talked about, the sound pressure level below 69 across the range. That's including all the speed points and all of the on-load, off-load conditions with recirculation valve, etc. The overall IP rating of the system is IP67. That's of the full package itself. So I know some of the connectors on there, especially the customer electrical interfaces, will be IP 6K, 9K rated, but the full package is rated at IP67. And then one of the other testing figures we wanted to put on here was the 500-hour salt spray test that's been passed. So as a baseline, we have 500 hours of salt spray, but there's headroom in that for any customer-specific testing as required. In terms of voltage range, so the integrated motor drive unit, as standard, we have a 600 volt unit. So that covers a voltage range on the vehicle of 500 to 820 volts DC. That's the non-derated zone. If we go from 820 to 850 volts, we have a small derated upper voltage limit. And from 500 down to, I believe it's around 470, we have a lower derated voltage range for that 600 volt unit. But we also have an optional nominal 400 volt motor inverter unit that's exactly the same footprint. It integrates exactly the same way with exactly the same electrical interfaces that we can swap in to cover the lower voltage ranges. So anywhere from 500 down to 150 volts DC on the bus. The control voltage range across both of those is common with what we consider everything on the commercial vehicles to be, so from the 12 to 24 volt range. So that's going to be operating on your CAN and your low voltage control circuitry. And the max peak current draw we're going to see in operation is around 25 amps for that 1 minute peak. That's the capability of the motor. So we're recommending around 30 amp fuses, but that should be agreed as and when we know the installation requirements of your vehicle. The 29-bit CAN J1939 is the communication protocols we said previously, and the baud rate for that out the box will be 250K baud, but we can modify that again from 500 up to 1 megabyte and 1000K baud as necessary for your application. The last two slides then, we'd like to talk a little bit about some of the testing methods and specifications. So the TX01 units have completed and finished all of their testing. That's why we're now at the launch phase. So we have done a range of testing. It's not limited to what's on the screen at all. There's a full suite of testing and DVP that we've been doing as part of our validation program. But some of the key highlights we thought we'd like to mention here at the launch is as follows. So we've done the full pressure range and flow range performance mapping as you require. And that information can then be shared with you to make sure that we have the appropriate set points as part of your vehicle operation strategies. We've done full ambient temperature range mapping. So that's the from the -40 level all the way up to +65 for the intake. We've done that as a third-party environmental chamber facility. And during that, we've tested all the duty cycles from 10% up to 100% to ensure that we are covering, and we've validated through physical testing that range of the product. For our life endurance testing, we've completed our internal 30,000 stop-start cycles, which we have finished and continue to do to go further than we need to on that. We've already validated it, but we're keeping it going to make sure that we keep our endurance testing data up to date. And we have got the 2,000 hours as a minimum on-load testing as well. And again, we have machines going further than that just for our own interest and to make sure that we are continuing to understand exactly how this product is working in the field. Then some of the ISO standards. So for the determination of the airborne noise, we've stuck to ISO 9614, which added a UCAS accredited facility, and there also was done the structure-borne noise to ISO 27270. So we have all the information for that, which will allow you to help model into your systems or do any of the calculations you need for the vehicle architecture. We can provide that information for you. Vibration testing has been completed to fully validate the framework and the mounting strategies and to prove that we don't need those anti-vibration mounts anymore. That was done to the SAJ2380 standard, which is equivalent to a battery pack standard, which we feel is equivalent in terms of the weight and size of the product, which allows us to validate the unit on board the vehicle. And again, that salt spray testing of 500 hours was done to the ISO 9227 standards, which is pretty industry standard. Which is one of the corrosion testings that we've done, and that's the one we decided we'd like to show on here. We've done those 500 hours. We can go further if necessary. And then lastly, the quality certificates and standards. So in terms of the facilities at Redditch where the units are built, so the units are built and adhere to the Machinist Directive for CE marking, and now with the UK CE marking that's required in the UK, the Supply of Machinery and Safety Regulations. So those two we're fully compliant with, and we have all the documentation to back that up, and it becomes part of the certification that comes with the machine. The electrical drive, the combined motor inverter drive, and the electrics have all been designed and tested to the R100 reg for the EC Reg 100 on electrical vehicle construction and safety. And we have tested and passed the EMC Reg 10 requirements We are just pending the VCA approval on that to allow us to e-mark the product going forward with the correct e-mark serial numbers. And then as a business in Redditch, we are ISO 9001 accredited for our quality management systems, but also we are IATF 16949 accredited and have been for the last 3 years now. So that's the quality management system controlling our production line and all of our processes. And with that, I think we come to the end of the end of the presentation. So thank you very much for listening, guys. And we will now move on to a Q&A session. So I don't know. Let me get the Q&As up. One of the Q&As then. So will the product be available with an R10 EC certificate? Good question. Thank you very much. So yes, we're going through the approvals process with the VCA, and that's on our standard, what will be the G11 package, which is what will be brought to you through the launch pack information. I'm not entirely sure on the timings on that, but we will be able to provide a Reg 10 certificate at some point before the major deliveries we'll be doing next year. Okay, so we've got a question here then on delivery time. So deliveries, like everyone, we've been dealing with part shortages and challenges within our supply chain, but despite that, we are already in small batch production for some prototype vehicles. And with our robust forecasting system and working with our suppliers, we are now accepting orders for TX01 units, and deliveries will be scheduled for Q1 of 2023. So that's when we can expect to deliver. So we are taking orders now, but deliveries will be starting from Q1 2023. Is external cooling with liquid required? Yes. So this is a water-cooled unit. So the coolant requirement is up to 50/50 water glycol. There's one port into the compressor system at the motor end, and then we internally link it to the compressor cooling system. And then there's one discharge port. So there's one in and one out on the vehicle interfacing side. But yes, it is a liquid cooled compressor. Is the 24-volt control voltage the actual limit? Typically in a vehicle, we'll see voltages a bit higher. Yes, good question. So no, it's not. So that's 12 to 24 volt as nominal. I believe the full range is from 9 volts up to 36 volts on the communication side. So that will cover the full range of the standard fluctuations on the vehicles. Got here. Are you planning to transfer some of these improvements of the current compressor range back onto the TX02 units? Yes, so that is something that we are planning to do. So the improvements we've made with the minimum pressure valve and the logic we've done for some of these strategies for low temperature running, we will be moving back onto the TX02 range as well. So that means that we have consistency across the whole TX series in terms of being able to handle those larger environmental conditions. What about the cooling needs? What flow is required? What is the heat to coolant figure? Again, very good questions. A lot of this information will be part of the launch pack as well on the full technical data sheet. I can tell you that as a minimum, you'd be requiring 5 litres a minute of coolant flow. And the coolant temperatures will also be part of that launch pack information. And then the heat to coolant figures will vary, obviously, depending on the speed and the pressure rate range that you're working in on the compressor. But we have that information, and we can share that information with you as part of your vehicle strategies. Do you have these units running on trucks or buses or both? So the TX series, we are targeting the truck and the bus market, and most commercial vehicles and specialty vehicles in the hybrid and electric and fuel cell range. So it really depends on the flow range of the vehicle requirement, but yes, we do have these running on trucks and on buses. The TX01, we're thinking primarily is going to be focusing on the truck market, just because inherently the truck market uses less air requirement on the vehicle. But the TX02, which we launched a couple of years ago, as I said, has already got some very robust market presence on buses. Are rubber dampers needed for the vehicle installation? So as I said, from the testing that we have done, so through the vibration testing of the package and then the structure-borne noise testing we've done of what's transmitted back to the chassis, we don't believe that rubber dampers are needed anymore. We have a recommended hard mounting strategy for this, and that is indeed how we've tested and how we've designed for. But obviously that comes down to a customer decision as well at the end of the day. If it's something that you feel is a requirement for you, or you want to take our data and analyze it through your vehicle system, then we can offer, because we do have on some of our other ranges, those rubber dampers. That is something we can do, but specifically for the TX01, we are not recommending that. We can hard mount this as part of the chassis and frame interface. Will a 24-volt compressor be available in future? Or this is something that we have discussed. I'm not entirely sure if that's going to be part of any of our future offering. It would definitely come down to the market demand. Certainly from what we've done in this development cycle, we've seen the majority of our customers who possibly even started going down the 24-volt route go back to high voltage for these auxiliaries because of the power that they take when they're supplying the air. So it could be a possibility if we see it as a need in the market, but for now we've not planned any 24-volt compressor at this size. Do you have any data on energy consumption in comparison to the current product in similar operation? So yes, so we have got full mapping of both the TX01 and the TX02 units, so we can of course give the comparison data to you, looking at the different set points. So from the data that we've seen so far, what we see is that we're very much on par with the TX02 in terms of the exact speed and flow delivery points drawing the same power requirements. But we can obviously provide data as necessary for your vehicle operation. So we've got a question here about servicing. So we will be recommending annual service for the filters and the oil on the compressor system. So a 1-year service in line with the vehicle servicing that happens. And then there will also be a recommendation for every 5 years to have an overhaul kit for continued long life service on the vehicle. So for the design life of the compressor, the life is currently about 15 years on vehicle, and that's following the recommended service and maintenance intervals. And then in terms of the service training, we will be providing free service training online. We can arrange in-person training for those who want it at cost to some select customers and business partners, but we will be providing all service training online for free. And then in terms of our service centres, we have hubs throughout Europe. We also have the capability back at our Redditch facility here as well, of course. But we do have those service centre hubs and part of our distribution network, which will be there to help for servicing and overhaul as necessary. Let's see if there's any more questions coming in here. Is the new unit interchangeable with the current unit? So I wouldn't necessarily say that the TX01 is being deemed a replacement for the TX02. They're very much going to be side by side as a family in the TX series range. In terms of the low voltage and high voltage connectors, we have tried to have continuity there. So we'll be using the same HVA280 high voltage plug connector for the high voltage side and the same HDSCS family for the low voltage connectors. But as you can probably appreciate, with the reduction of footprint and with the reduction of weight and things, the mounting points will have changed slightly, especially as we've now decided to remove the AV mounts on this design because of the benefits we see from that. So we have carried across the same size of fittings and fixtures for the air discharge and for the water coolant ports. So there will be continuity in terms of the threaded parts and the pipe work and things, but it's the exact position. As you can appreciate, it's a smaller unit. Those positions have slightly moved, but we wouldn't, as I said, we wouldn't necessarily think of the TX01 as a replacement for the TX02. It's very much part of the same family, and it comes down to the vehicle requirements in terms of flow requirements, what you really need on those vehicles. Do you supply compressor software for controlling the recirculation valve and safety function in case of overheating and controlling its operation? So the recirculation valve is purely mechanically driven, so that operates on its own, and also the function of it acts as the relief valve on the unit, so it has a double function. The software itself, as I said, with that minimum runtime feature, will pair with the recirculation valve, but it will never, that recirculation valve will never fail into a safety critical condition. It will always, because it is being used as the pressure relief valve, become open when it's needed. And in the case of overheating, we have the temperature cutbacks available within the motor inverter unit itself. So we have full control of derating the compressor as and when there is an over temperature condition. So we will always come to a safe state. So yes, the presentation, as I said, it will be made available. I believe this will be going online on our website and will be part of the launch pack that will be sent through to you. So as Arne Freeman, our marketing guy, will be sending out launch packs as soon as possible, I think, after this webinar has been concluded. And that will include this presentation, so the slides you see here, the data sheets and the launch flyer that we have for the TX01 units. Just see if we've got any more questions. Why don't you include a rain cap on the inlet filter as standard? So those of you who are familiar with the TX02 product probably know that we do offer a rain cap on the intake filter if necessary. Again, this comes down purely to the position of the unit on the vehicle and whether it's deemed necessary in the installation approval that we will do, whether we deem it necessary based on exposure to the elements and what the likelihood is of direct water going into that intake filter. What I will say is that the intake filtration system that we use has a cyclonic action with a drain valve on there. So any water that is drawn in will be thrown out and will be allowed to drain out of that intake filter before being allowed to be sucked into the compressor intake itself. But if there is a situation or there's an installation where we feel that that you would benefit from that rain cap, then that is definitely an option we can still offer. Another one on delivery time. So again, we are accepting orders now and the units will be ready for delivery in Q1 of 2023. And will there be an air-cooled option in the future? So an air-cooled option is something that possibly might be something. It's something that we're not looking at the minute. With the integrated motor drive unit, we've currently integrated into this TX01 unit, which allows us the small footprint and the small weight that we have. Currently, we only have that as a water-cooled option at the minute. I think, again, that would come down to a real need in the market for it, or whether we see that as potential big growth business for us. And I think we'll probably wrap it up there then. I can't see any more questions that have come in. Okay, so yes, so thank you very much, everyone, for joining the webinar this morning. We've been really excited to share this information with you, and hope that it's been useful for you, informative. Any further Q&As that come in, there will be some communication links sent out as part of the launch pack as well. So there will be a way of you getting your answers if you haven't had anything answered on this call that you want. As I said, the launch pack will be sent out as soon as possible. And thank you very much for your time. It's been our pleasure to present this to you this morning. So thank you very much, and have a great day.